Hey guys, going to introduce you here to Unit 5 that we have coming up, and we got some more algebra concepts. So I think some of you are really enjoying the algebra piece to this and the learning kind of the ins and the outs of the basics of algebra or pre-algebra. So this next unit ties right into that as well. So we just got done with expressions, and this Unit 5 is going to go into equations and inequalities. All right, so in your notebook, I want you to put a new heading on the next clean sheet of paper you have that says Unit 5, Equations and Inequalities. So go ahead and pause this, write that in your notebook, and we'll move on. So there's two big terms that we need to know to start, and that is what is an equation and then what is a solution. So you can either pause this now and write these definitions or listen to me for a while and then pause it, but this all of this needs to go in your notebook. So however you want to do it. So I'd either pause it and write it or else listen and then pause and write it, okay? And think about what you're writing. So first thing is an equation. So an equation, is a little different than an expression. And we've talked about this. An equation is a mathematical statement that two expressions are equal, right? And it doesn't say algebraic expressions, so these expressions may or may not have a variable with them. The one thing about an equation makes it much different than an expression, that they contain an equal sign, okay? So basically, and like I've talked to you before, you can kind of think of an equation as being the pivot for a seesaw, right? And whatever I have on one side of the seesaw, it's basically just saying that what I have over here is equal to what I have over here. So a lot of times we get caught in saying, well, this is the answer to this. No, what it's saying is what I have on one side, this expression is equal to the expression that I'm going to have on this side. Okay, and we'll look at an example here in a second. When we talk about solutions, or a lot of times we might say solutions to the equation, the solution is the value of the variable, if it's present, that makes the equation true. So here's a prime example. All right, make sure you copy this down with its labels and everything. So here we have an expression, x plus 9. That's an expression. It has two terms in it. We have a variable and we have a constant. Over here we have an expression, no variable but two constants, 16 plus 3. So this is an expression, this is an expression, and this equal sign is saying, listen, we're saying that this expression is the same as this expression, okay? So this whole thing together, these two expressions being set equal to each other, we call that an equation. In this case, the solution of the equation, the value of the variable that makes the equation true, is x equals 10. And you think, well, why? Well, because if I would substitute a 10 in here, 10 plus 9 equals 19, and over here 16 plus 3 equals 19. So the value of 10, x being 10, would be the solution making this equation true. All right? So make sure you get all this down nice and orderly in your notebooks. If you have to pause, whatever you need to do. So let's look real quick at a couple examples. And the answers to these are just yes or no. So go ahead and write these examples in your notebook as we do them. So determine whether the given value is a solution of the equation. So is the given value, is the value they give us, a solution of the equation? So the first one, pretty basic, right? Number one says 11 equals n plus 6. This is a semicolon to say, hey, the value that they're giving us is n equals 5. So there's the value of the variable. So basically this is saying, hey, if I substitute a 5 into here, will that be a solution to the equation? Will it make the equation true? So over here we have the expression 11. And if we would substitute in a 5 for n, we're going to get 5 plus 6. Is 5 a solution to the equation? Does 5 make this equation true? Well, we know that 5 plus 6 is 11, and so that it's equal to 11. So our answer for this one would be yes. Okay, so again, is the given value a solution to the equation? So here we have y minus 6 equals 24. They give us y equals 18. So we need to determine, is 18 a solution to this equation? So go ahead, plug it in, see what you think. In this case, if y equals 18, we're going to plug in 18 right here for y. Minus 6 equals 24. So is 18 minus 6 the same as 24? Is this expression equivalent to this expression? And the answer is no. 18 minus 6 is 12. 12 is not 24. In this case, we would say, no, these two are not equal. And there's a little sign for that. You go, bloop, that means not equal. So the answer to this is no. The value that you gave of y equals 18 is not a solution to this equation. Down here we got x over 9 equals 4, and they're asking us, hey, here's a solution we came up with. Is that a solution to the equation? Is x equals 36 a solution? Well, we know that x over 9 means 36 divided by 9 is equal to 4. So here's our expression of 4. Here's our expression 36 divided by 9. Is 36 divided by 9 equal to 4? It is, so we're going to say yes. Go ahead and pause it and do the last one. So here we have 15t equals 100. They say, hey, t is equal to 6. So is 15, so we have a coefficient of 15. Remember, this means times t. So 15 times, they're telling us replace that t with 6. Does that equal 100? Well, let's check it out. 15 times 6. 6 times 5 is 0. 30, carrier 3. 6 times 1, 90. Whoop, no way. That is not equal. So in this case, the answer would be no. So finding solutions to equations is really just taking the value of the variable they give us, plugging it in and saying, yep, it's going to make the equation true, or no, it is not going to make the equation true. Okay? So here we got writing equations to represent real-world situations. This is on page 298 in your book. All right, 298. So if you want to turn to page 298, that'd be a great idea right about now. So go ahead, I'll give you time. Open to page 298. And we're going to take a look at 5, 6, 7, and 8 down at the bottom. So we've done a lot with writing expressions. Now we're being asked to write an equation. So we know as soon as it says write an equation, we're going to have an equal sign in here somewhere, right? That's what I have over here. Must have an equal sign. So Marilyn has a fish tank that contains 38 fish. So we know it contains 38 fish. There are 9 goldfish and F other fish. We don't know how many other fish, okay? But what we're being asked to do is write an equation to represent this situation. Well, it looks to me like she has 38 fish total. And we know that that's going to be equal to the 9 goldfish plus the F for other fish. So here is one equation that would work. We could also write it as 9 plus F, the 9 goldfish plus the F other fish should equal 38. If we were asked, what's the solution to this equation? Right? Go ahead and think about that. What would the solution to this equation be? Well, let's see. What would F have to be to make this equation true? If you happen to say it would have to say 29, you'd be correct. So F equals 29. If it asks us, it doesn't ask us, but if it asks us to find a solution, we'd say, well, right there's our solution. F equals 29. Let's go to Juanita. Juanita has 102 beads to make N necklaces. Each necklace will have 17 beads. Okay? Well, I know she has 102 beads total. And I know that from those 102 beads, she's going to make necklaces that each have 17 beads on it. So we need to sit back and think, well, how could I represent this? Okay, so I got 102 beads to make N necklaces. And I know that each necklace will have 17 beads. So let's think. I could subtract them. That could equal 102, but that's not going to really make sense. If this is me, I'm thinking, well, my 102 beads, I'm going to take 17 beads for each necklace. So 17 times the number of necklaces would give me 102. Okay? Another one I could possibly write, maybe you would say 102 beads divided by the necklaces would be 17 on each necklace. All right? Maybe I would say 102 divided by the necklaces whoops, I'm sorry, divided by, let's change that. 102 divided by 17 on each would give me the number of necklaces. Okay, so any of those would work. And then I could find the solution to that equation. I think in this one, probably this one would be the one I like the most for if I'm writing an equation. Go ahead and try this one. Pause the video and go ahead and try this one. All right, so you have a chance for this one. This one says, Craig is C years old. His 12-year-old sister, Caitlin, is 3 years younger than Craig. So his 12-year-old sister is 3 years younger than Craig. Okay? So his sister's 12, and that's 3 years younger than Craig. This is an interesting one. So in other words, I think what this is saying is, if we take Craig's age and we subtract 3, we should get his sister's age, which is 12. All right, so maybe you came up with this equation to represent that situation. All right, maybe you came up with, well, if his sister's 3 years younger, that means if I took his sister's age and I added 3, what's going on here? And I added 3, that would equal Craig's age. That could work. All right. Maybe if I take Craig's age and I subtract his sister's, I should get 3. So any of these would work. I think I like this one the best to represent this particular situation, but they're all going to give me the correct solution to the equation if I solve for C, which in this case would be 15. The last one, Kim rented skates for H hours. The rental fee was $2 per hour, and she paid a total of $8. All right, so she rented skates for H hours. We don't know how long, but we know that for every hour, she paid $2. And in the end, she paid a total of $8 for the skates. Okay, so I believe we're taking $2 times however many hours she's going to skate, and in the end, that would be 8. So our solution to the equation in this case, H would equal $4, right? But they didn't ask us for the solution. They don't say anywhere in here, well, how many hours this would be 4 hours, sorry. They don't ask us anywhere in here how long did she skate for, did they? But if they did say, well, what would the solution to the equation be? Well, we know she would skate for 4 hours because 2 times the number of hours should equal the total of 8. So there's your equation there, okay? So there are some different ways you can go about it, but to represent them the best, I think I like this one the best, this one, and this one. All right, so they just take a little bit of practice. What I'm going to have you do is turn to page 300, and we're going to ignore this spot right here. That doesn't apply to us, but I want you to turn to page 300 in your book, and for tomorrow, you can start it now, but for Monday, I want you to complete page 300, okay? And be ready to go over that and discuss that on Monday. So page 300 in your book, and you can go ahead and get started on that, all right? So good job. Got any questions, let me know, and we'll meet on Monday and chat about page 300. And more equations, more solutions, and kind of take it to another step. All right, go ahead, get to work.